variable relations are modeled by the exponential equation. So at the end, you guys remember, we ended up with something that looks like this, a value and then a base, right, to the power of x. Do you guys remember that we almost ended up with something that looks like this when we did the other examples, right? So A represents what? The initial value. B is the base. And then if B was greater than 1, then we call it exponential growth. And then if B, I wanted to change this to between 0 and 1, because B technically is not negative. If B is between 0 and 1, then it models a decay. All right, so let's look at an example here. A city's population can be modeled by the equation P equals to 1.4 and then times 1.0415 to the power of T, where P represents a population in millions and T is T years after 1985. In which year did the population first exceed 3 million? So, what's my beginning population? 1.4 million, right? So my beginning of population is the 1.4, but it's in million, right? Because population, it says right here, it is in millions. Now, the question is asking me to find how long or in which year did the population first exceed 3 million. So they gave me my final population. What's my final population? 3 million. And we know it's a growth, right? Why is it as a growth? Because the base is above 1. Now, what would be the rate that the population is growing at? What percentage? The rate means percentage. What percentage is the population growing at? Do you guys remember how did I get that 1.0415? What did I do to the rate to get 1.045? Add it to what? To 1. So I had to do 1 plus the rate, right? And I ended up with this. Right? So if I want to find the rate, what do? Subtract 1. Right? So if I subtract 1, I'm going to end up with 0.0415, and in percentage it's going to be 4.15%. Right? If I multiply this by 100, it's going to be 4.15%. Okay? So if I want to know what the rate is, I have to take my base and I have to take away 1 from it because I have to add 1 to my rate. So, the question is asking you to solve for t, because it's asking you for which year, so I'm looking for t, knowing that your final population is 3 million. So that's our grasp method. So what is given to me? I know that the initial value is 1.4, so I already know that. I don't have to write it. I know that the final population is 3. Yes? What am I looking for? T. And my equation that I'm using is B equals 1.4, 1.0415 to the power of t. I'm going to plug in 3 for t, for p, sorry. And then I'm looking for t. Now, how do I solve for t? What do you want to do? T is the next point. I can't take it. What do I want to get rid of? That's the last thing, because that's the one that's where you have the t on top. So I have 1.4 times 1.0415 to the power of t. So what do I want to get rid of first? 3 is on this side, so I can't get rid of it. But
1.04.
I want to get rid of the 1.4. So there is a multiplication right here, right? So if I want to get rid of that 1.4, if I want to bring it over, what does it become? Division. That's 2, 9. Yeah. Now, how do I solve for that t? Do you guys know any method to solve for that t? Probably you don't know anything other than try to plug in values for t, right? So let's try and plug in some values for t. So this is what you're going to have to do. You're going to have to stick on your device, calculator, and then you're going to have to sit and do 1.0415 to the power of whatever. 1.0415 to the power of whatever until you reach a value that's close to 2.1429. Okay? Now, do you start with like small values? Do you start with like 2 and 3 and 4? Do you start with these small values? No. Right? Because, I mean, 1 to the power of 2 is still almost 20. Right? So we're going to start with doing trial and error. So what about 40? 50? Okay. 15? Okay, so can you guys do 15 for me? 15 is too much? Okay, what did you get when you do 15?
13 something.
If you did 1.0415 to the power of 15, I got 1.8.
18 and 19.
So if I put 15, it was 1.84. So 15 is too small, right? Because I want 2. I want this. So Dylan, you're saying it's going to be?
20.
Between 18 and 19.
So if I do 18, what do I get?
If you do 18, you get
2.07. Okay. So 18 is going to be 2.07. 9. And then 19. 2.165, right? And I need 2.14, so that's close, right? And because I want it to exceed 3 million, right? So basically, I'm getting more toward this because this is going to be still less than 3. Okay? So we're going to say after doing the trial and error, we were lucky that we found it right fast. Usually, like, it takes a little bit longer time. But we're going to say that The question is asking you in which year. So they want the year. What do you do?
So add
1985
with
with 19. Yeah. So what is that? 2014 or 2004? 2004. So in 2004, in that again. In 2004, the population will exceed 3 million. So for this specific thing, I will teach you a method to solve for that exponent, even though that it's not in the curriculum for the grade 12C, but it's a useful method that you guys should know to solve for exponents. We only use it when we're solving for exponents. So this explains the two special cases which I've already explained to you, right? Do you guys need me to go over this? They use the value A naught, which A0, that means that's the initial value, which we use small a for, okay? Doesn't matter, it's the same idea. A0 is your initial amount, okay? Are you guys okay with that? And then D is your doubling time. And H is your half-life time. Okay, so what can I do in order for me to solve for that exponent, right, if I know y and a, for example? So let's look at an example because it makes sense with an example. So if I have 5 equals to 1.06 to the power of x, what would you want to do to solve for this? Trial and error, plugging in values for x, right? So you can start plugging in values for x and try to find. Okay? You guys go ahead. I'm going to do my thing on the board. Let's see who's going to... I can't even find it on the calculator. It's taking me time. You found it? I don't know if this calculator... No, this is a different calculator. Do you have one? This calculator? Oh, that's right. Just 1 second. 27.6. I find it to the decimal. How? And this is what I'm going to teach you right now. Okay, so here's what we're going to do. So anytime we're looking for an exponent, we're going to follow the following method. It's called the logarithm method. So the log is the, you know how the square root is the opposite of square? You know how the nth root is the opposite the logarithm. So they're the inverse of each other. Okay? So this is what I do. Whenever I'm looking for an exponent, we take the log of both sides. So take the log of both sides. Okay? So in this case, it's log 5 equals to log 1.06 to the power of x. Okay? So all what I did right now is I took the log of both sides. So I wrote log for both sides. What log does, because of the way it's inverse, it makes that exponent come down. So the exponent is not an exponent anymore, it's a multiplication. So that's going to be log 5 equals x log 1.06. Right? Now it becomes a multiplication. So for me to get rid of that multiplication right here, what do? Bring it over, and it becomes a division. And now x is by itself. So that is the magic of math, right? And then you can enter this on the calculator. There's a log button on your calculator, and you can do log 5 divided by another log 1.06. Okay? Are you guys okay with this?